Hello everyone. So continuing with our design pattern series, in this video we will cover strategy design pattern. So let's get started. We will start with what is a strategy pattern, why we use it, how to achieve it, its code implementation in C++, and finally its benefits and disadvantages. So let's get started. Let's start with what is a strategy pattern. So a strategy pattern is a very simple pattern. It's first of all a behavioral design pattern, and it let you define a family of algorithms, also called as strategies as the name, into their own classes and make them interchangeable dynamically. Now when you will learn about this pattern, it will look like a very trivial thing to do and maybe very easy thing to do, but once you know that this pattern exists and this is a valid thing to do, it becomes easy for you to implement it in your own projects, right? It also allows the client to choose any strategy without changing the code structure. So all of this will become clear when we learn about why and how. So first of all, let's start with why strategy pattern. So let's take an example of a sorting library. Let's say you are creating a sorting library, and this is how your so you have exposed just one function called sort. It accepts an array and it does the sorting. So very simple. Now let's say over time your client start demanding that they want to define their own sorting strategy. Maybe someone want to use bubble sort, someone want to use quick sort, merge sort, and so on. So the natural way which comes to the mind is that okay, we will expose a type parameter which client can pass, and based on that type we will execute the particular sorting strategy, right? So if it is bubble sort, quick sort, merge sort, any strategy, if it is based on that, we will sort. Now there are multiple issues in this approach. First is, as written here, any change in any algo can affect the entire class. So it is a very bug prone approach. For example, let's say you want to modify your bubble sort code, but you are touching the same file. So it might be a possibility that a bug could be introduced in other type of strategies which should not be touched, right? The other issue could be, let's say there are different developers. One developer is working on maybe optimizing bubble sort, and one developer is working on maybe fixing a bug in a quick sort code. Now since they both are working on a same file, same class, whenever they will submit the code, there could be merge conflict. So there is always a issue because everyone will be working on the same huge file. And as we can see, the class can grow over time. If a client start demanding more strategies, the same class will bloat over time. And this is never a good idea to keep everything in a single class, right? We all know about separation of concern principle. So what is that? Is there any other way we can use? So one other thing which comes to the mind is this structure. If somehow we can keep all of the code in a separate class, bubble sort, quick sort, and merge sort, and so that each class can be used for any strategy. So when you see this structure, it looks like an inheritance, that we can have a base sort class and we will have a subclass for each strategy, sorting strategy, which looks okay, right? But there are certain issues here as well. For example, let's say client wants to use bubble sort. So you will create an object of a bubble sort class and give it to the client. Now if client want to modify their strategy in between in their runtime, right, maybe quick sort, if they want to switch to another strategy, it is not trivial. They have to create a new object for other strategies. So what if, is there a way to keep the object same but to be able to switch between strategies? So that we cannot solve using inheritance. So whenever something doesn't work using inheritance, you should always think about something called as composition, right? Composition is, there is no inheritance, there is no subclasses, but a class contains object of other classes. That is what composition means. So let's see how strategy pattern achieve it. So now what do? We create only a single class which is exposed to the client, which is a sorting context. Now a client only has the object of a sorting context class. But what does this class is? This class does not have any logic of sorting strategies. It contains another object of a sorting strategy, and here we create an interface of sorting strategy, and all of the strategies implement that interface. So now sorting context will contain the object of any of the sorting strategy, bubble sort, quick sort, right? And the client can set any strategy it wants. So client can set the strategy to be bubble sort or quick sort, and sorting context will have the object of that. So basically client is not storing the object of bubble sort or quick sort. Sorting context is storing the object. Client only store the object of sorting context. So client doesn't have to change its object. And sorting context will always issue the sort function of the sorting strategy. So basically every bubble sort or quick sort, since they are implementing this sorting strategy interface, they have to implement this sort function. So sorting context always knows that it can call that sort function of that strategy, and that strategy will be implemented. So this is a composition. So sorting context contains sorting strategy. It does not inherit. So yeah, so that is the difference between inheritance and composition. Maybe in some other video I will explain all of these different types, but for this video we should know that for sorting, for strategy pattern, we use composition, not inheritance. So I hope this makes sense. Now let's see the code for this. Now we will see code implementation in C++. So here let's start with sorting strategy. We create a sorting strategy interface. There is no way to create an interface in a C++, since all of its functions are virtual. It is essentially an interface only. So it only has a sort function. So anyone who basically extend or implement this class will have to override this sort function. So bubble sort, quick sort, and merge sort. And if we quickly see, in bubble sort we are just printing, we sort using bubble sort, sort using quick sort, and merge sort. Now let's see the sorting context. So sorting context has an object of a sorting strategy, and you can also, it also has a set strategy function where you can change the strategy, and also it has a sort function which client will use. Now here in the sort, you just call the sort function of the strategy you have. So you don't have to think about, so sorting context does not contain any code regarding how to sort. It just calls the sort function of the particular strategy it has. And in the set strategy, a new object is passed of the strategy, and you just update your variable. Now one thing to note is, if you already have a strategy object, you have to delete it explicitly. You can't just update it, because in C++ there is no garbage collection. So you will have memory leak if you do not delete the objects automatically, manually. There are smart pointers in C++, but that is a different concept. Now let's look it all together in the main file. So you create an array, you create a sorting context, and you pass new bubble sort. So you pass a bubble sort strategy, and when you sort, now when you call the context sort, it will sort using bubble sort. Now you can change the strategy of this object with quick sort and also merge sort. So let's see, if we see, it will show accordingly. So when you call the sort first time, it was sorting using bubble sort, second time quick sort, and third time merge sort. So this is how you can change your strategy, and accordingly context will execute that strategy. So that's it regarding the code. Let's come finally to the benefits and disadvantages. So benefits, as we can clearly see, we can swap algorithms used inside an object at runtime. So at runtime you can call that set strategy function, and you can choose any object you want, any algorithm you want to use. It isolates the implementation detail of an algorithm from the code that uses it. So there are separation, you can see there is a sorting context which only contains which strategy to execute, and the respective strategy code lies in a different classes. So again there is a separation of concern here. We are definitely, it is extensible for new strategies. You can always create a new strategy implement that sorting strategy interface, and you can link that strategy in your context. So these are the benefits, and finally the disadvantages. There are a couple of disadvantages. First is, if the number of algorithms are limited, right, and fixed, let's say you don't want to add or remove algorithms over time, and number of algorithms are also limited, so then there is no need of strategy pattern. There is no need to introduce these additional classes and interfaces. You can only have single class which contains the entire logic, right? All of these patterns comes into the picture when you start scaling. The second point is, which is important as well, that client must be aware of different strategies to be able to select the proper one, right? So if you see the client, in the client code, client is passing which strategy to use. So client should be aware of all the strategies that are possible, and they should be available that of the usage of all strategies, because the code gives client control to choose any strategy. So client should be basically mindful of all the strategies, which is a reasonable expectation, and that is where you will use this pattern when client knows all the strategies and they want the control over it. If the client doesn't want the control over it, then there are other patterns you can use. So that's it about the strategy design pattern. I hope this video helped you understand what is strategy pattern, where we use it, how to achieve it, and so on. If there is any doubt, please let me know in the comments below. And if you find this video helpful, please like this video. And I have made a lot of other design pattern videos, so you can find the playlist here in the screen, on the screen. So I will keep making other system design videos as well, so stay tuned. For that, you can subscribe the channel as well. Until then, I'll see you in the next video. Bye everyone.